Harvard's top scientist says it could be a nuclear-powered alien craft. An object zooming through our solar system is challenging notions of scientists and sparking heated debate.
The call went out. An object unlike any seen before was speeding through our solar system. 3I Atlas, an interstellar comet, commanded immediate attention. Its trajectory, at one point appearing to be on a direct path to Mars, prompted Harvard astronomers to issue warnings and spurred NASA into an unprecedented observational effort.
This is really exceptional. You have to be an interstellar object to be going that fast at that distance from the sun.
This isn't merely an astronomical curiosity, it's a cosmic event. We're talking about a visitor from beyond our sun's gravitational pull, carrying potential insights into alien star systems and the very fabric of the cosmos. The implications you see are truly staggering. The red planet's near miss. The universe in its boundless expanse often holds surprises that challenge our perceptions. One such surprise, a celestial object designated 3I Atlas, burst onto the astronomical scene, immediately capturing global attention. Discovered by a telescope in Chile, this wasn't just another comet. It was swiftly identified as an interstellar comet, only the third such visitor ever confirmed. This fact alone sent shivers down the spines of many scientists. You see, most comets we observe are local, originating from ice worlds still bound by our sun's gravity. But 3I Atlas was different. Its trajectory clearly showed it was an uninvited guest from beyond our stellar neighborhood, moving with an incredible unbound velocity. When 3I Atlas first entered our solar system, it was traveling at a staggering speed of around 36 miles per second relative to the sun. To put that mildly, this is a speed that makes even our fastest spacecraft look sluggish. This hyperbolic trajectory, meaning it will eventually leave our solar system forever, was a key indicator of its interstellar origin. This immense speed, coupled with its initial path, quickly sparked widespread discussions and even alarm about a direct path to Mars. While the term direct path often suggests an imminent collision, the scientific community, particularly Harvard astronomers, began to raise questions. The initial buzz was understandable. An object this large and moving this fast, appearing to head towards a planetary body, would naturally trigger concern. And what many overlooked is that the nucleus of 3I Atlas is estimated to be quite substantial, potentially up to 3.5 miles across. For comparison, that's larger than the island of Manhattan. This immediate sense of urgency prompted scientists to deploy every available resource to track and analyze this mysterious object. Harvard physicist Dr. Abraham Avi Loeb, a prominent figure in the search for extraterrestrial intelligence, was among those who quickly raised questions. He noted that early observations of 3I Atlas showed an unusual glow, suggesting it was active far earlier in its approach than typical comets. The most shocking fact is that its trajectory was also coincidentally aligned with the orbital planes of our solar system's planets, a 1 in 500 chance. This raised the unsettling possibility that its path wasn't entirely random. NASA, while maintaining a more conservative scientific stance, certainly didn't ignore these discussions. The agency's focus immediately shifted to observation and data gathering. The prospect of studying a pristine sample of material from another star system was an unparalleled scientific opportunity. But what further secrets would this interstellar wanderer reveal as it drew closer? The icy heart of 3I Atlas. As 3I Atlas continued its rapid journey, scientists worldwide mobilized their most powerful instruments to peer into its enigmatic nature. What many people are crazy about, you see, is the drama surrounding interstellar objects. Yet the real story lies in the extraordinary scientific revelations. The James Webb and Hubble Space Telescopes provided stunning images, offering crucial insights. This visual evidence began to steer the scientific consensus away from more speculative theories and firmly towards its classification as an interstellar comet. The most shocking fact is that 3I Atlas demonstrated activity at distances where most comets from our own solar system remain dormant. This early brightening, which initially puzzled astronomers, was eventually explained by its unique composition. Observations revealed an astonishing carbon dioxide ice to water ice ratio of 8:1, one of the highest ever recorded for any comet. To put it mildly, this is a game changer. Carbon dioxide ice, or dry ice, turns directly into gas much more readily than water ice. This explains why 3I Atlas began forming its coma, that fuzzy bulb of gas and dust, so far out in space, beyond Jupiter's orbit. This peculiar chemical fingerprint provides a priceless glimpse into the conditions of its birth in another star system. It suggests that the parent system of 3I Atlas might have been incredibly rich in carbon dioxide. Analyzing such pristine, ancient material allows astronomers to piece together what planet formation might look like in entirely different cosmic neighborhoods. The closest approach of 3I Atlas to the Sun is set for late October 2025 at a distance of about 130 million miles. While the initial headlines screamed about a direct path to Mars, the reality is a significant but safe distance of 18 million miles from the red planet. This is still a remarkable celestial rendezvous offering unique observational opportunities for our Mars-based assets. NASA's Curiosity and Perseverance rovers, currently exploring the Martian surface, were poised to observe 3I Atlas at night. The thing nobody tells you is just how difficult it is to get detailed information on fast-moving, faint objects from such vast distances. We are watching, in real time, a piece of another galaxy revealing its secrets. But what larger lessons can we learn about the universe's grand design? Defending our solar neighborhood. The appearance of 3I Atlas isn't an isolated event, but a dramatic reminder that our solar system is constantly interacting with the wider galaxy. Before 3I Atlas, we had Oumuamua in 2017 and Borisov in 2019, both confirmed interstellar objects. Each of these visitors, like cosmic driftwood carried by galactic currents, offers invaluable opportunities to study materials from beyond our Sun's gravitational influence. A mysterious, elongated object sparked intense debate about its shape and nature. Borisov, on the other hand, was clearly a comet. You can see this everywhere. The universe is not a static place, but a dynamic, ever-changing environment. These interstellar wanderers are thought to be ejected from their home star systems during chaotic formation processes. They then drift through the interstellar medium for millions of years before accidentally crossing paths with another star system. The sheer scale of this journey is almost beyond comprehension. The fact that we are now capable of detecting these fleeting visitors is a testament to our technological advancements. While 3I Atlas's trajectory brought it 18 million miles from Mars, the discussion around a direct path still highlights the ongoing importance of planetary defense. NASA's Planetary Defense Coordination Office, or PDCO, is dedicated to detecting and tracking near-Earth objects that could pose a threat to Earth. The most shocking fact is that even a relatively small object could cause regional devastation on Earth, while a larger object could trigger global consequences. The work of PDCO involves detection, characterization, and mitigation, including strategies like kinetic impactors, which were successfully tested in the DART mission. What many overlooked is that Mars itself experiences numerous impacts. Its thin atmosphere offers less protection than Earth's, meaning even smaller meteors can reach its surface. On average, Mars is struck by hundreds of meteorites annually. So, while 3I Atlas wasn't going to impact Mars, the red planet is no stranger to celestial encounters. The rapid response to 3I Atlas showcases humanity's growing capability to understand and respond to cosmic events, pushing the boundaries of what we know. But could the uniqueness of 3I Atlas harbor a truth beyond natural explanations? Unexplained mysteries of 3I Atlas. The arrival of 3I Atlas reignited a captivating, albeit controversial, discussion. Could some interstellar objects be more than just natural cosmic debris? Many people are crazy about the idea of alien life, and when an object like 3I Atlas behaves in unexpected ways, it's hard not to let imagination run wild. You see, the early, unusual brightening of 3I Atlas was a major point of intrigue. Harvard physicist Avi Loeb was at the forefront of this more speculative line of inquiry. The thing nobody tells you is that when scientists encounter data that doesn't fit existing models, they naturally explore all possibilities. Loeb's argument centered on the idea that if natural explanations failed, then the possibility of an artificial origin should not be dismissed. He even put forth the tantalizing, though unproven idea that 3I Atlas might be generating its own light. To put it mildly, these were wild conjectures, but they were rooted in observations that at first glance seemed to defy conventional cometary behavior. Another factor that fueled his hypothesis was the comet's trajectory. He highlighted the improbable alignment of 3I Atlas's path with the orbital planes of our solar system's planets, a probability of roughly 1 in 500. These statistical improbabilities, he argued, might suggest a sent towards the inner solar system by design scenario. However, as more sophisticated observations rolled in, the scientific community largely settled on a natural explanation. Its distinct coma and tail, its high carbon dioxide content, and its overall behavior strongly resembled that of a comet. So, for people watching this, wondering if this is proof of an alien arrival, the time has come to look at what we know for sure. The thing is, when you strip away the speculation, you are left with a single profound scientific event. The saga of 3I Atlas highlights the increasing frequency with which we are able to detect interstellar objects. The universe, it turns out, is teeming with such travelers. While the more sensational claims did not hold up to closer scrutiny, they served an important purpose by forcing the scientific community to rigorously test hypotheses. As 3I Atlas now recedes back into the vastness of interstellar space, never to return, its legacy is one of profound discovery. It has broadened our cosmic perspective, showing us that our solar system is not an isolated bubble, but a temporary port of call for objects journeying across immense distances and eons. The lingering whisper of the anomalous. As 3I Atlas receded, its tail fading into the cosmic tapestry, a profound silence settled over the astronomical community. The initial flurry of observations, the data analysis, the consensus, all pointed to a natural cometary phenomenon. Yet for some, the neatly packaged explanations felt incomplete. The universe, in its infinite complexity, often presents us with puzzles that defy immediate solutions. And 3I Atlas, for all its scientific clarity, left a lingering whisper of something anomalous, a faint echo of possibilities that conventional science struggles to categorize. Many people are crazy about the idea of order, of predictable celestial mechanics. But what if the universe is a stage for far more intricate dramas than we allow ourselves to imagine? The rapid deactivation of 3I Atlas's coma, for instance, once attributed to its high carbon dioxide content, began to nag at the edges of some minds. While dry ice sublimates readily, its complete dissipation so quickly after its closest approach to the sun felt too efficient. It was as if the comet had performed its act and then, with deliberate swiftness, folded its theatrical curtains. To put it mildly, this wasn't typical cometary behavior, which often leaves behind a more prolonged, gradual fading. The thing nobody tells you is that when a scientific explanation fits too perfectly, especially after initial confusing data, it can sometimes mask deeper, unresolved questions. Dr. Avi Loeb, ever the provocateur of conventional thought, continued to press his inquiries. He argued that the early activity, followed by the swift cessation of outgassing, could be interpreted not as a natural process, but as a controlled emission. What if, he posited, the observed activity was merely a strategic venting, a deliberate act to mimic a comet and thus avoid deeper scrutiny? This was, of course, a wild conjecture, but it stemmed from a pattern of observations that, when viewed through a certain lens, seemed to suggest intelligent design rather than random cosmic chance. Consider also the sheer velocity of 3I Atlas. While its hyperbolic trajectory confirmed its interstellar origin, the precise speed and angle of its entry into our solar system raised eyebrows. The universe is vast, and the probability of any interstellar object crossing paths with our relatively tiny solar system is astronomical. Yet, 3I Atlas did not just cross paths, it performed an almost graceful flyby, a trajectory that allowed for maximum observation without any risk of collision. This wasn't merely a near miss, it was a cosmic pirouette, executed with an almost uncanny precision. You see, statistical improbabilities, when they pile up, can sometimes point to more than just coincidence. They can hint at an underlying, perhaps even directed purpose. Loeb and his supporters also revisited the comet's composition, particularly the unprecedented 8-to-1 carbon dioxide to water ice ratio. While explained as evidence of a carbon-rich parent system, they questioned why such a composition would be so prevalent in an object designed to traverse interstellar space. Carbon dioxide, being highly volatile, would sublimate far more rapidly than water ice, meaning an object predominantly made of it would have a shorter active lifespan. Unless, of course, the rapid sublimation was desired, a method for quick concealment after a brief observational window. This isn't just a scientific curiosity, it's a profound challenge to our assumptions about interstellar voyagers. What if the very chemistry of 3I Atlas was a form of cosmic camouflage? The direct path to Mars narrative, though scientifically debunked, held a symbolic resonance that refused to die down in certain circles. While the closest approach was indeed 18 million miles, the initial trajectory, the media frenzy, and the Harvard warnings all contributed to a subconscious sense of a deliberate targeting. What if, it was whispered, the apparent threat was not of impact, but of observation? Was its unique path truly just a fluke, or are there hidden forces guiding these interstellar visitors? Like and subscribe for more mind-bending space stories.